For starters here, I'm going to have you go ahead and warm up by factoring that quadratic expression. So go ahead, pause the video and do that now. You can kind of see my work there if you missed it, but you basically should have gotten 2x minus 5 times x minus 3, or x minus 3 times 2x minus. What we're going to talk about today is 5.5, which is quadratic equations. What's the difference between an equation and an expression? Really not much. The only difference is now this might have equals 0, or it might say equal 1, or it might say equals y. Basically, it has an equal sign. So now we're dealing with quadratic equations that have this equal sign. This zero product property, it's really not extremely important. It is a vocabulary that might show up on some state or standardized testing. So in that sense, I kind of want you to know what a zero product property is. But as far as what it represents, not extremely important. Excuse me. Okay, so like for this, what the zero product property is, they're basically saying if A times B equals 0, then that means either A has to equal 0 or B has to equal 0, because anything times 0 is 0. So using this zero product property, if x plus 3 times x minus 7 equals 0, that must mean x has to equal negative 3, because negative 3 plus 3 is 0, and 0 times anything is 0. Or x has to equal 7, because 7 minus 7 is 0, and 0 times anything is 0. And the reason I said negative 3 and 7, because like I mentioned here, if that was negative 3, it would make that parenthesis 0, and if this was positive 7, it would make what's inside that parenthesis 0. So essentially that's what the zero product property, and we can use that to solve quadratic equations. We can solve them by factoring. So basically all you have to do is get your equation equal to 0 and then factor it, and you can use then your factors to find the value of your variable that might equal or make your equation equal 0 then. All right, so let's walk through this here. Okay, biggest one, I'm going to start here. 2x squared minus 11x equals negative 15. Well, you might say, hey, this was our warm-up, wasn't it? And it was. The only difference is now we have it equals something. What we need to do is get rid of that minus 15 on the right-hand side and put all of our terms on one side of that equation. So we're going to have 2x squared minus 11x plus 15 equals 0. So like I did in the warm-up, how do I get my first term? Well, 2x times x. And then my last term is 15. Its only factors are 1 and 15 or 3 and 5. So of course I use 3 and 5. And I said, hey, 2 times 3 gives me 6. And then 3 plus 5 gives me 11. The only issue is that's a negative 11 and this is a positive 15. So since the sum, this is a sum here, it means our signs are the same. Because this is minus, that means they are both minus. So there is our expression, which in our warm-up we were done. In this case, we're actually not done because we have this equals 0. So this is where the zero product property can come in now. Because we can look at this factor here and say, all right, now what's the value of x that makes that equal 0? So this is a little bit harder than the example I showed you on the previous slide, because right off the bat, you might not know the value of x you can plug in to have equal 0. So the nice thing that we can do is we can set that factor equal to 0 and then solve for x, and that tells you what the value is. So x equals 5 halves or 2.5. So that is the value of x that when plugged in here will make this factor equal to 0, which will then make this equation true. All right, so x equals 2.5 is one of our solutions, right? Because this has a degree of 2, it's going to have how many solutions? Boom, you got it, 2. So then we can do this one a little bit easier to see. Might not have to set it equal to 0 because I know 3 minus 3 is 0. So x equals 3 will be our other solution. So there is our two solutions that make this equation, this original equation, true. And then we can work our way through these other examples as well. So looking here at y squared plus 15y plus 36, well, we need to solve that by factoring. So same thing. The nice thing here, it's already equal to 0. I don't have any greatest common factor, so now we just factor. How do I get y squared? Y times y. 36. Ooh, now this will take a little bit of time. Let's list our factors of 36. And voila, there they are. And I am thinking it's going to be 3 and 12 because positive 3, positive 12. We have 3y, 12y, which adds to 15y. And so then y equals negative 12 and y equals negative 3. Go ahead, pause the video. Do this one. And right there is my solution with probably the least amount of work possible to show. But if you have questions on that, make sure you do not hesitate to ask. Now, we might have other equations like this. We might say, all right, well, let's use the same theory we did and factor them. So I'm going to go ahead and do that quick. Please don't worry about writing all this down. I know it showed up very quickly. But basically I went through and the first two I factored. You can see it's basically when you only have two terms, that you have that middle term of 0 there. So you're trying to OI to 0, which is happening as you can see there, as it's factored. So in the first one, we get x equals negative 2.5 and positive 2.5. In the second one, we get x is positive 6 and negative 6. And in the third one there, the 3x squared minus 24 equals 0, I couldn't get past, I factored out the 3. And then I have x squared minus 8, and now there's nothing I can factor, because there's nothing that will OI to 0. So there's actually another way we could solve these, and it's actually probably faster. So let me show you that here quickly. And what's nice is anytime we have two terms or a group squared equaling a number, again, two terms, we can always solve it by finding square roots, or as we get further in these lessons, by cube roots, fourth roots, whatever. So what's nice here is we can isolate the squared term. So I'm going to add 25. So we have 4x squared equals 25. Then I'm going to divide by 4. And I get x squared equal, and I went a little bit further ahead than I wanted to. We get x squared equals 6.25, and then we square root both sides. Now remember, because this is x squared, it could be a positive or a negative number. We don't know. We just know that the outcome is always positive. So we have to put this plus or minus out in front, because it could be a positive x or it could be a negative. So then we have to do the plus or minus the square root of 6.25, which is plus or minus 2.5. So x equals positive 2.5 and negative 2.5. So the exact same way, or the exact same answer we got as solving it by factoring, but maybe a little bit faster. This next one. This is even faster than the first because our x squared term is almost isolated already. All we got to do is divide by 5. We get x squared equals 36, and then follow the same process. Square root both sides, we get x equals plus or minus 6. Again, a positive or a negative 6, or and a negative 6. So now that we know how to solve by square rooting, we should be able to answer this last question, which we couldn't do solving by factoring. So we get 3x squared equals 24, and then why don't you go ahead and pause the video and finish it. Okay, what you should have gotten there, you probably typed it in your calculator and just left it as plus or minus square root of 8, or rounded it to 2.83. Now the actual correct answer here is plus or minus 2 square root of 2. And because this is more exact or more accurate than this one. Now these two are the exact same amount of accuracy, it's just this is not simplified. And you know, mathematicians, we always like to simplify everything. And if you don't know how to go from the square root of 8 to the 2 square root of 2, we can talk about it. Okay, here are 4 more problems. Actually, 2 of them you've kind of seen. But with this, solving by graphing, you might have said, well, you didn't graph anything. And you're right, I haven't. With this first problem here, I solved it by factoring. I subtracted the 18, factored it, got x equals negative 9, x equals 2. With this one, the same, where I solved by square rooting. I moved, because I noticed there was only 2 terms. I moved the 25 over, divided by 4, square rooted, got x equals plus or minus 2.5. Third one, I tried to set up by factoring because I couldn't do square rooting because there are 3 terms, not 2. But then I got x squared minus 2x minus 4 equals 0, and I got stuck because there's no factors of 4 that will OI to negative 2. So then I did the same thing with x squared plus 1/2 x minus 1/4, and I said, okay, how can I factor that? I listed my factors of 1/4. I know there's probably more, but I got stuck and I couldn't go further. And I can't square root them, so then you say, well, all quadratic equations should have solutions, right? So why can't I find them? Well, there's another way we can do it, and it's called solving by graphing. So let me show you this very quickly here. Okay, here's our first one, the x squared plus 7x equals 18. So I did the second step of subtracting the 18, getting it equal to 0. Then I could just type in the expression of x squared plus 7x minus 18. And for those of you that haven't noticed, I'm at Desmos here. So I typed that expression in, and then look at what you see here. Look at that x-intercept. 2, 0. Look at that x-intercept. Negative 9, 0. Look at your solutions. X equals negative 9. X equals 2. So that's really cool, is your solutions are your x-intercepts. They're your zeros. They're your roots. All those words mean the same thing. So basically what I'm doing by solving this is I'm finding where our parabola is crossing the x-axis, finding the value of x that makes the equation equal to 0, which is pretty neat. So the second one, 4x squared minus 25. Now you can put equals 0. I just didn't like what it did to our graph. It doesn't even make it look like a parabola anymore. So I just kept it as the expression. And look here at our dots, negative 2.5, positive 2.5, exactly what we got here. Let's look at this example, the one that we couldn't solve before. And here might be the reason why. If you look, these are accurate as they can get. They're decimals. They're irrational numbers, I guess you could say. They're not rational. So that's why we couldn't use factoring or square rooting, because it's an irrational response. Yes, it's rounded. So in this case, x squared minus 2x minus 4 equals 0 has a solution of x equals positive 3.236 and x equals negative 1.236. And let's look at this last one. I zoomed in a little bit so we could see it better, but let's look at those x-intercepts, and there you have it. So there's your solutions. So you can also solve quadratic equations just by graphing them and finding the x-intercepts. Now graphing them and finding the x-intercepts on your graphing calculator is a little bit harder, but there are steps you can follow to do that. Make sure any questions you have, you write them down, and you can ask them tomorrow in class. One last thing I wanted to address here quickly is just, let's review. Think. There are 3 ways you learn how to solve quadratic equations. Brainstorm right now. What are they? Think about them. Hopefully you said all 3 of these. If not, go back and watch the one you missed.